Hello guys, my name is Carlos and I'm gonna introduce you the metabolism of glycogen in animals. This is a biochemical process, a metabolic pathway for energy reservoir. It's like an energy reservoir. You have to remember this, that glycogen is a polymeric form of storage in vertebrates and many microorganisms. Another molecule that it's a polymeric form for esterase, but exclusively in plants, is starch. Okay, you have to remember that. But we're gonna focus here in the molecule glycogen that it's exclusive for animals. So, in vertebrates, glycogen may represent up to 10% of the liver weight and just 1 to 2% of the weight of the muscle. So we have a higher demand of glycogen in liver than those in muscles. So this is important to remember. Another thing is that glycogen in muscle provides a quick source of energy for either aerobic or anaerobic metabolism. That's why when we do excessive exercise, we demand a more amount of oxygen and glucose. So as the glucose go down, the concentration of glucose go down in the glycolysis, we use glycogenolysis to produce glucose by glycogen. So another thing to remember is that glycogen is reserved in granules in an hepatocyte. As you can see here, these things like circular things in the cytoplasm in the cell form the glycogen, and these big things they are mitochondria. So we're gonna go further to the glycogenolysis and the glycogenesis. What is the difference? As the name suggests, glycogenesis is the formation of glycogen, and glycogenolysis is the degradation of glycogen to form glucose that can be further used to synthesize another molecules in different metabolism pathways. So we're going to start here with the catabolism of glycogen. In skeletal muscle and liver, the glucose units of the outer branch of glycogen enter the glycolytic pathway through the action of 3 enzymes. This is important to remember. These 3 enzymes are gonna be implicated in the degradation of glycogen to glucose. These 3 enzymes are glycogen phosphorylase, glycogen debranching enzyme, and phosphoglucomutase. I'm gonna explain better what is the activity of these 3 enzymes in this image around here. We're gonna start by 2 essential enzymes. As you can see here, we have the glycogen molecule, and this is the branch that we are talking about. It's characterized by a glucosidic bond between the carbon number 6 and the carbon number 1 of the branching molecule. It's a glucosidic bond with alpha 1,6 linkage, and there is a portion here that it's the reducing end of the molecule and the non-reducing end of the molecule. Here we have the glycogen phosphorylase that's gonna to catalyze the the breakdown of the non-reducing ends of the molecules, forming glucose 1-phosphate molecules, monomeric units. And we're gonna have here the portion of glycogen that's gonna be break in the next processes. Well, this is just the process of glycogen phosphorylase, the degradation of the non-reducing end. Next, we have to introduce the debranching enzyme. This enzyme has two different activities. The aminotransferase, here we have transferase of this molecule here, the non-reducing portion of the glycogen is gonna be added to the linear molecule of here of the glycogen. Then the second activity is the breakdown of the branching of the alpha-1 site linking of the glycogen. So this enzyme is gonna catalyze the breakdown of this linkage here, and we're gonna have glucose free in the cytoplasm, or it's gonna be transported by another pathways, metabolic pathways. So this is basically the activity of these two enzymes. But we have a third enzyme, as you remember here. We have them where it is. Well, I lost it, but it's around here. We have this portion. In the first step, we produce glucose 1-phosphate. As you remember, we had the monomeric subunits of glucose 1-phosphate. So what are we gonna do with that molecule? Well, this is the phosphoglucosamidase activity here. It's gonna use to produce glucose 1,6-biphosphate that is more usable for a glycolysis, for example. First we have this, the phosphoglucosamidase. It's an enzyme that has the serine residue with that phosphate group, well, with that phosphate group actually. There's gonna be a nucleophilic attack in the portion of the Pernod's ring of glucose 1-phosphate here, and it's gonna be phosphorylated in this portion in blue. So this molecule is very unstable, so it will tend to free another phosphate group back to the portion of the serine in the enzyme. It's gonna be an electrophilic attack here, and the phosphate group is gonna return to the enzyme, and this will be ready to another activity of phosphoglucosamidase. And in the product we have glucose 6-phosphate that can enter to the glycolysis and produce, as you know, the products like 2 molecules of pyruvate or NDH, etc. Basically, that is the glycogenolysis. Thank you.